everyone. Thanks for joining our webinar today. Today's webinar topic is exploring the fundamentals of digital production in a modern dental lab. Our presenters today are Greg Everett and Nick Alonge from Sierra Dental Tools. So now I'm going to turn it over to them.
Hey, Katie, thank you, as always.
Thank you, Katie.
So first off, I want to kick this off and say that everybody's going through a pretty hard time right now. You know, there's a lot of labs that are stagnant, you know, and it's happened across the industry, across the world, frankly. And you know, our core message at Sierra, our core drive is to bring as much help and value to the dental lab as we can as a company. It's really a core value for us. And we had some meetings last week and decided, you know, let's do a webinar that's not around a product. We're just going to say and talk about the digital process in the lab and offer our insight between Nick and I on what labs are, you know, what we can do in the processes to make them more efficient. So what we're seeing here is this is not updating on my screen. I can't read the slide. That's awesome. Okay, so getting into it here. So the whole deal of the digital workflow is that you really want to think about it as its own entity. It's like its own animal. It's like an organism, and it has all of its little parts that all need to work together. And there's ways to make certain parts of it more efficient. There's ways to mess up certain parts. And the point of this webinar is we're just going to go by step and give you our top thoughts, our top insights on each part of the digital workflow. You know, we look at it like an organism or a chain, and you definitely got to think about the strength and the efficiency of each part, and then how it comes together at the end. So by the time you guys are done here, hopefully, you know, we've given somebody some insight where they can maybe affect their bottom line in the right direction in their dental lab. So jumping on into it here, scanning is obviously the first thing that we're going to talk about. You know, after we've got our model work done, that's the entrance to the digital workflow. And so it's really the main pillar of what's going on. So we're gonna go over a couple of our quick tips with scanning. And firstly, the models need to be very dimensionally accurate. We'll talk a little bit about the benefits and drawbacks of pin models versus solid models, and then some tips and tricks on how to do a good die trim just for digital. So I'll turn that over to Nick here, and we'll head that direction.
Hey guys, my name is Nick Alonge. Just want to give you a little background about myself. Been in the industry about 20 years. Grew up in my dad's dental lab. Learned a lot from him because he was big into lean manufacturing. Sorry about that. And from there, I moved on to another lab and then large production facilities. And found a niche where I really like helping people. So I'm here to join the Sierra team and help you guys out. Just started back in March, so this is gonna be an exciting time for us. Let me carry on to what we're trying to do here for scanning. As you guys know, the most important thing that we get here is models. Digital models need to be super accurate. Same with, you know, traditional models. The biggest thing that we have a lot of times is impressions that come in faulty. Either it has a pull that's going on, has a tear, maybe there's a bubble in the impression, or when you go to the next step, you pour it up and it has a bubble in the stone model and you're trying to fix those. That's kind of where we're trying to focus on first right now, is that when you're scanning in, the model itself is extremely, extremely important. With that, move on to, if you can't see it, neither can the scanner. That's a big thing that we see a lot of times, is you're looking at the model in your hand, you're like, maybe I'll scan it in and see it. Well, if the scanner doesn't see it, the nice thing is you can take a screenshot of that and send it to your doctor. So the doctor then can give you an evaluation of, do we proceed with the case or do we get the patient back in and re-impress? If it's a digital scan, sometimes they send it to you and within minutes you can look at it, tell the doctor, hey, can I get another area of this scanning in because it didn't pick it up? You know, we have holes in the scan. Sometimes there's little blurs that go on because the doctor moved too quickly with the scanner. So those are some of the variations that we've seen from model accuracy from the digital side and the analog side. Now, we're going to move on to, go ahead, Greg, you got something on that?
Oh, I was gonna share an anecdote here. You know, I used to, back before I worked with Sierra, actually skipped over my background. I've also been in it for over a decade and kind of grew up in the industry. You know, I'd spent a lot of time in the lab doing the manual processes and all the digital processes. So became pretty good at helping people troubleshoot and make things more efficient. Whenever I was talking about digital scanning to dentists, you know, the main part of that is, hey, you got to talk about line of sight, because if they don't get the tissue retracted, if they don't you know, if they don't have the angle of the wand correct, the scanner can't see it, and neither can, or if you can't see it, neither can the scanner, and you end up with data that's not good. And so that concept ports over in the lab on the benchtop scanners and in the intraoral scanners. And generally in my experience and Nick's experience, you know, if you have a doctor that takes good impressions with polyvinyl, they're usually going to be pretty good adopting that digital scan. And the opposite's true. If you have a doctor that's bad at polyvinyl, they're also going to be bad at digital. It's not really like your catch-all. It's not a magic pill. So, you know, as a laboratory, you really still have to support them, even if it's digital, as far as you know, how to actually do it correctly. Yeah, I'll punch it over here to Nick. We'll talk a little bit about the model construction and the best model for digital and scanning.
Yeah, thanks, Greg. One of the things that I have instilled in the different labs I've worked at, I've learned that solid model scanning is the most important. The biggest thing is that you want to get everything as clean as possible. You want to have it as natural as it was when they prepped it. So what I've seen a lot of times is when the bottle is cut out and the die is trimmed, and then you go to push the model onto the putty to get it scanned in, you go through all the design work, gets milled, the guy gets it out of the mill, puts it in the sintering oven. It's a day later, all of a sudden they have it open, the whole occlusion's open. And you're thinking something's wrong with the milling machine, the tool's bad. And you don't really think that the whole thing happened because this guy scanning it in raised the die up. I mean, it happens all the time. I mean, pretty much probably once or twice a month it'll happen on a regular basis. So that's the big thing of scanning in the solid model just for that purpose, is just to make sure the die doesn't get raised up. The other thing I prefer to get too is I want to have, especially anterior work, I want to have the tissue there so I know what I'm doing when it comes to closing black triangles, the blanching on the tissue. You get a little bit more adaptation. You can always scrape it back when it goes to seat.
Right.
That's one thing that's nice. If it's scanned in, you can always remove it. But if you scan in something that's not there, it's very hard to rebuild it.
Yeah, you don't want to be guessing with digital. I mean, it's a real accurate tool, and you know, the more data that you can acquire and become and digitize, the better, right? So, you know, and then there's also the whole thing about bite precision and cross mount. You know, you have more surface area, right, for that digital matchup to happen. You know, the more scan data you have, the better. The more points that the software has to do that alignment. You know, for us, you know, when we're talking to labs, Nick will agree with me. It's all about reducing the variables that you have in your system and eliminating them. So if you can eliminate the variable of the pin model, by all means, do it. You know, start articulating that thing and doing a separate die, or have your pin model separate in the pan. You know, however you want to work with it, but the master model should be scanned.
The other thing I want to interject too on this, and it gets skipped over, is if a doctor takes a full arch scan, and it might only be for one posterior crown, scan in the full arch. That way it's in there. It really helps the designer use some of the functionalities of the software to go through movements. A lot of times it's a quick thing. You can go and copy the opposite side of the arch and stick it right on. You're done. You don't really have any designing to do. So there's a lot of advantages to scanning in the solid model when it comes to this. And scanning in whatever models the doctor gives to you, and that's where cross mounting comes in. If you've die ditched a model and then you've based it, you lose the arch or you lose the mandible area that you would do to capture a full arch bite to try to get something in. So two of us are really big advocates of scanning in solid models compared to pin models.
All right.
So
well,
we'll move on to the next all important, the die. To me, it's the most important part of the aspect here. It starts with a good impression. We all know that. If you get a good impression, you're going to be able to get a good product out the door. The next is using quality die stone with the correct expansion ratio and pouring it without bubbles. I mean, you're pouring a tiny little die, hopefully, you won't get any. The other thing I've learned too in this aspect is pouring the individual dies first and then removing them, because a lot of times the impression material gets stuck into the die stone and you screwed yourself right there. So since you're going to be scanning in a solid model anyway, and then you're going to be doing a die separate model, you're going to be able to pick up all of that and have a rigid model. Now, I always pour up 2 dies, one that's my scanning in die and one that's my test fit die for later. Those are some important things there. The other thing is when you're die trimming, mainly bulk trimming die, take your time with it. I've come across a lot of labs that have over trimmed that when it gets to the actual die trimmer, the one that's doing the majority of the heavy lifting when it comes to the trimming of the dies. If the margin's been removed and he didn't catch it, or he wasn't the one that did it, he's going to then finish cleaning up the die, give it to the scanner. Scanner's never going to know. The only person who's going to know is the QC manager at the end of the line when he goes to fit it on that brand new die and the margin's open or it won't fit because the margin was removed in one section. I mean, Greg knows more about this than I do on this.
That's the most irritating thing in the lab is when there's like an avoidable thing. Like, man, I hate doing a remake or sending something all the way back through because we had a nicked margin or something. So, you know, using that master die as a reference point helps cut down on all that. And then I've got a little bit of a spiel on die trimming, I guess you could put it that way. Just for digital. Now, when you're trimming a die for just for manual processes, you know, it's user preference, but there actually is some nuance to doing it for digital. And the point is that you don't want to over ditch it or under ditch it. You want to go right down the middle. And the reason for that is because if you over ditch it, you create an undercut that the scanner may not see, and so you'll end up with missing data. So if you've ever scanned a die and saw little holes or whatever underneath the margin, you're over ditching it. And then if you under ditch it, there's the possibility that your automatic margin recognition in the software won't pick the margin up because it's looking for a sharp transition. It's got an algorithm inside that's looking for that margin. And if it's under ditched, it might think it's just surface texture. So if you look in our little picture here, the bottom one is the ideal die trim. That thing's perfect. You can also see it in F. You know, it's nice and crisp, but it's not overdone. And that'll work every time, all the time in digital. So there's a lot of nuance to just model work and scanning. You know, but I'm sure we could talk for 2 hours on those. But moving on to the next main step of the digital process here, let's talk a bit about design. So designing is there's always a big learning curve for labs that are first adopting it because, you know, it's difficult for somebody who's gone from being at the bench for 10, 15, 20 years and then trying to do it on a screen. Like there's a pretty crazy disconnect there. It just takes time. And so we've got a couple of points to look over here. We'll dial into how to get the right library selection. We'll talk a little bit about computer skills and how those are involved. And then the biggest one is control input efficiency, which we'll elaborate on that here in a sec.
So one of the big things that I've taught lots and lots of people on designing is less is more. That's a big thing. I'll log on to somebody's PC that are asking for assistance on the design, and I'll notice they have 200 plus clicks on a single posterior crown. And you can go back and look through their designing, and you notice like they were doing the micro movements first, meaning adjusting the anatomy and moving the occlusal before the crown's even like connected at the margins. So I'm a big advocate on moving the crown into position, overall getting the size, using the tools, getting the right dimensions on the buccal and lingual corridor by looking down the distal ridge. The other thing is making sure that your contacts are set, bringing them out, looking from the occlusion down, or even rotating the case over if it's been trimmed right. You can look from inside. You can see how much touch the crown has to the contacts. Once you get that all set, then move on to your micro movements, which is adjusting the occlusion. A lot of people don't utilize the auto features of the software. Yeah, some of them are kind of glitchy, and they all have their own little, as we call them, nuances.
Character.
But that's adaptable. Yeah. So, like some people want it out of occlusion 3/10 because when it goes to the mill, it actually is only 1/10 out, or 2 pieces of credit card material. I mean, there's different things that the more that you design and the more that you're talking to the finisher, the better those crowns are going to come out. But most people don't spend the time touching every button in the software. I mean, we're going to talk about this later, but I get manuals and I just read them because so much is in the manual. The other thing is a lot of these softwares, this little question mark in the top in this picture, you click on that and it tells you what each one of these tools does. Spend some time learning these.
It's important. And I think one of the good ways to look at the design process, just think about it as big to small. You do your positioning, you get it all done, and then you go in and do the tiny little movements. And, so if you think about it in that way, you just become more efficient at it. And I actually have a kind of offside tip for designing. Read the manual, figure out what the hotkeys are. If you don't know what a hotkey is, it's like a computer shortcut that you can use to select tools or have the software do something. And then go on Amazon, spend $30 and buy a programmable gamer mouse that has buttons, and you can actually map those hotkeys to those buttons. And what that enables you to do is that you don't have to take your hand off the mouse to move the keyboard when you're working, and makes you a lot more efficient. When I discovered that, I had designed 80,000 crowns by the time I figured that one out, and it was night and day. I was like, wow, I'm 30% faster because I figured this out. So anybody I'm talking to design, I'm like, buy a gamer mouse, just do it, and you'll.
So this is where it gets a little different for me because I grew up with my hands on every single case.
Yeah.
I actually purchased what they call a 3D connection mouse,
right,
which allows the model itself to move in one hand and your working instrument to work in another one. And that kept my efficiency very high. I mean, on a regular day, I was doing between 60 and 80 designs in a day. That's not scanning. That's just working through the designs and then turning over and asking the finisher, hey, I got some questions on this. Will you move to the next slide real quick, Greg? We'll go over this.
We're moving into it here. Yeah, no worries.
Yeah, so this is the thing here. Like we were talking before, if you have more than 25 to 30 moves on a single posterior crown, you're touching it way too much. And you're wasting time in the design side. And sometimes when you overdo it, when it goes through the processes, then the poor guy that's finishing is recontouring stuff because it's not what he saw.
Yeah.
So the communication between the designer and the finisher, we're going to reiterate this time and time again, is extremely important for efficiency. We had a cool thing at one of the labs that I worked at and learned through was every 5 cases, the finisher would come over and like, hey, I want to reteach you how to do this or read to go about this case. Because as we know, we're making one-off units every single day. Never a crown is identical. Even our remakes are changed in some way or another, and that's something that where even if you do it perfect and you walk away and you come back and you're like, oh, this is all wrong. Who touched my stuff? Nobody touched your stuff. You're just getting another set of eyes on it. And that's the whole thing here, especially with big arch cases. I've always recommend if you're spending every 15 minutes that you're working on the big case, just step away, walk around, come back and look at it, because then you'll notice, oh, maybe this doesn't match or that doesn't match, or you've noticed some other features going on. The other thing here is when you scan in a full arch and you have the opposite side and the restoration looks like it would fit, just copy, mirror it, and move it over, and your design is 80-90% there. So big advocate on using the tools of the software to its efficiency.
Yeah, well, and that's a theme throughout digital is, just learn the tools and be aware of them. And if you're having, so I've encountered people who have difficulty just using like Windows, the computer itself, and I recommend make a point of learning that stuff. Know how to right click, know how to copy paste, know some of the basic shortcuts and stuff like that. Because if you're staring at a screen all day long doing this, every single little thing like that you can learn is going to help you and keep your stress level down. And it's all good, the way you look at that. So we'll jump into our next digital process, which, man, it's pretty hard for us to not rant super long on each one of these, because
we should do in the next one, each one of these steps we should just do an hour about. There's so much that we're cramming into this today.
Oh, for sure. So, once our design's done, everything, we're all happy with it, we got to get it nested. And a lot of times we find, in both Nick and my experience talking to labs, it doesn't really, most labs, it seems, tend to overlook this step in terms of how they can gain efficiencies and get rid of waste in their process. But this is like the low-hanging fruit here. If you nest certain ways, you can make better use of your material. You can cut down on your post-processing, and that all comes down to how you're doing the nesting job, how you're feeding the machine, and also your strategy selection and how that's all set up. So, Nick, why don't we talk a little bit about material usage here?
Yeah. So I walk into a lab. I'm probably going to say this a ton of times because I do walk into a lot of labs, and I'll walk over to the CAM software because that was a niche that I really enjoyed getting into, because I spent a lot of time designing, but milling, nesting, that was always an overlooked when I went to a lot of these labs. Overlap the units. You can get a ton of more. You can probably get 3 units more in a puck from nest overlapping them. There's also different techniques to nesting it as well. Doing it in smaller batches. Greg and I will talk about this, which we bring up, is as soon as you walk into the lab and your day starts, I have seen multiple people in order to get the mill running, they nest 20 units in one puck. They're sitting there and turning the connectors and rotating it on there to get the most of it.
30-minute process. And
they spend 30, 40 minutes trying to do that. And then they hit calculate and they walk away. And there's another 30, 40 minutes. The mill still hasn't even started its day yet. Like, it's sitting there doing nothing. That'd be like you hiring me to come to your lab to evaluate your stuff, and I go in and I grab a cup of coffee and I sit down for 2 hours. I'm not doing anything. So the big thing is go in, throw 4, 5, 6 units in there, start the mill. Greg will iterate this, that if it's not running, it's not making you money. You're just paying it to sit there and do nothing.
I spent a lot of time managing a milling center, and if your investment, machine isn't running, it's not making you anything. If it's not producing, you're losing money. And so, like, the first thing you do when you get in there, get the thing running. Just put enough in to get you the runway that you need to get those bigger nestings done if you're going to do it like that. And then also, one thing we didn't talk about before, Nick, was, if the more units that you're able to get in a puck, like in that 5-10 unit range, the more efficient the program is, because your bulk reduction is all done at once. When compared to a single. So let's say a single takes 25 minutes to mill. If you mill 6, 7, 8 units together, your per unit mill time will be 23 minutes because there's gains there for batching. So top tip here, get the mill running, keep it running. Your mill's down, your wallet's down. And then batch strategically. Think about how, if I've got two A2 cases or 7 A2 cases, don't do it in two batches, put them together. And one other thing I think we covered here is when you're nesting for better material usage, don't create an island, which I'm sitting here and I've got the cursor on. That's wasted material. And so is a peninsula. So if you're creating little Floridas, you're wasting material. The best way to do it is to go back and forth and just chew the puck away from one end, kind of like this one starting. So with that, Nick's very opinionated about sprue placement, so I'll give you that.
Yeah, so we'll move on to the sprue placement thing. I'm pretty, I don't know the term on this, but I have been in so many places that they're putting 3 and 4 connectors on them that are, 1.2 millimeters in diameter because that's less to finish. But you have 4 places now you got to touch with your handpiece. The biggest thing that always got under my skin is when I would spend time designing an anterior case, 6 units or more, and I cut the contacts in between them to making sure they're nice and broad and long, and then I give it to the guy that's nesting it, and the first thing he does is stick a connector right on the contact. And I'm like, oh, I feel so sorry for the poor guy that's going to try to seat this, because now more than not, people are going to over reduce that contact, and then now it's open contact, and the porcelain guy has to add to it. The other thing that hurts my soul is I'm building the anatomy of the facial following a wax up that is approved by the patient. They got their temporaries in, and there's a connector right on the facial of the tooth. And I'm asking the nester, I'm like, why did you place that there? Oh, I was told by my manager we have to put 3 on it no matter what. And it just puts me aside. So over the last 8 years of me spending lots of time nesting, what I have found out is putting 2 connectors, like the photo on the bottom left here, at an angle behind the contact areas, which is usually a very thick part of the crown on both anteriors and posterior crowns. That will keep the crown from falling out. You can also overlap nesting them. So overlap them like this and have the connectors on the outsides. And then you can do rows down the center of the puck to start out with. Yeah, it's extremely efficient. They're strong enough. Now, the only thing that you need to adjust is it needs to be a 2.5 millimeter in diameter for zirconia. PMMA, you can get down to 2. Wax, I'd still keep it at 2.5 because the wax has an oscillation when it's milling that it vibrates. The next thing that drives me bananas is when somebody puts a connector not on the height of contour. All CAM softwares these days give you a line around the restoration to put the connector on the height of contour. Now, I do understand there are certain times you don't want to put there, like on a full arch bridge, and you're putting them on the lingual, and you need to have them in the middle, or you need to put them on the thickest part of the units. Very important to try to get that. You'll get undercuts from the milling tools, and then you have to spend a lot of time finishing out.
Yeah, you'll end up with this huge triangle there, right?
Yeah, I can talk about this for a long time because I've been doing it for so many years.
A lot of grinding.
A lot of grinding. And that's the thing is, like, we're going to move on to when we get into after nesting, when to start finishing the units, finishing them down in the green state. So we'll step onto this one. Now, the next thing is milling strategies. The bigger thing that's going on these days is, do I want quality or do I want speed?
It's a trade-off.
You can't have both. It's a trade-off. So each lab has their own definition of quality and speed. You guys will all determine what you guys want for yourself. Some people want to add a 0.3 in the anatomy. That's good for them. No problem. Go for it. Strategies nowadays have that upgrade in them. Back in the day, they weren't always available. The other thing is making sure that the strategy that you chose matches the material you're using. I have gotten lots of phone calls that, hey, Nick, I broke another tool. Why? Oh, I'm cutting a nano composite material using, diamond tools. Well, that's not what it's meant for, man. Like, that's going to break. You need to make sure you're using the right materials to the strategy. They're trying to overlap. Most of the new strategies come up because people get software updates, because the developers in the software write strategies for the materials. They work with us on giving them the feeds and speeds for the materials because of the tools that we produce. Greg will talk about that in a little bit. The next thing is making sure the tools match your strategy. Greg was telling me the other day that he took a call about a customer and he's breaking tools. He broke 6 of them. What's going on? You know, your tools are horrible. What this, that? Greg logged in and noticed that the overall geometry of the tool didn't match up. You remember that?
Yeah, there was this actually comes up pretty often, and it's because laboratories don't update their software. You use a tool that doesn't, if your tool doesn't match the shape of the tool in the software, when it's calculating, it's trying to avoid collisions with material in the part. And if it doesn't expect the correct shape of the tool, it can slam it into the material. It can slam it into the sprue, and what that does, it overloads the tool and causes a breakage. So if you're breaking tools, as a rule of thumb, if tools are breaking, it's a symptom of another problem, and it's usually pretty easy to clear up. The tool's either being overloaded or it's being hit on something. That's something that we, between Nick and I, every month we probably clear up, half a dozen of those sort of issues. But it comes down to the update, because if you're current with your software, you're not going to have those problems. And so, what the conversation's always around, hey, you're 3 years back on your software. We might be able to patch this for now to get you by, but if you really want to have the most efficient and the best thing running in your lab, you got to stay updated. So huge proponent of being updated on software. It doesn't matter what the software is, just keep it updated. It'll cost you less in the long run. So let's move into one of my favorite parts of the digital process, milling, which is kind of one of those things where you're sold a machine, and machines are wonderful pieces of technology. They're amazing, but they're not magic. They still need attention. And there's a few things that you can do as a machine owner or an operator that are going to help you. And so first off, it's about cleanliness, calibration, and then tool selection. So I'll hand that back off to Nick here, and he'll rant at you a little bit about cleanliness.
Yeah. So not long ago, I went into a lab, of course. This is going to be an ongoing joke, I believe. And I'm probably going to steal this from Greg too, because he's also had this. You go in there and you're just in there to evaluate the lab and give them some pointers. And you walk in the mill room and the floor has zirconia dust all over it. And you go over to the machine and there's a pile of zirconia in the bottom of it. You can see zirconias everywhere. And the reason why they want my help is, they're breaking tools and they got lines around their units and margins are chipping. The tools are the problem to this, is what I've heard. So
no, it's usually the CAM software for the machine.
Yeah, well, we'll see here. So we go through and I spend an hour vacuuming it out and cleaning it and cleaning all the tools. I take off the case and the entire back of the mill, all electronics are just jam-packed with zirconia dust.
Nasty.
So I had to tell the lab owner, do you mind if I put this on a chair or on a cart and wheel it outside so we can kind of blow it off? Because the suction is not going to do anything for this. So we get it all clean, put the machine back together, calibrated it, and the units came out amazingly smooth like they used to. Didn't change a tool, left the exact tools in there. And it was hysterical to me because the guy running the machine just left it get dirty. It's like having a sick employee at work. They're just not going to put the effort into it. They just don't. And the same thing with this mill. So big advocate of keeping the machines clean.
Yeah, well, and if you're a lab owner or you're the guy paying the bill on the machine, it's about protecting the investment, because as we all know, zirconia powder is abrasive, and you might not think about it, might not be intuitive, but as that zirconia powder gets packed into the bearings, packed into the ball screws, the collet, all the little components of the machine that are moving, it causes them to wear out. And the more zirconia powder that you have in there, the faster your machine will wear out, and it's going to get loose over time, and then it's going to fail. And so, you know, the difference between running a machine that's cleaned on a regular basis and never cleaning it and just neglecting it, you know, you could cut the service life of the machine in half by neglecting it. Like it's pretty easy to do. So, you know, you're paying that bill. You may as well get the most out of it. You know, I'll just go ahead and take the collet thing, Nick. So another thing we run into a lot is collets. So if you're familiar with the collet, that's the part that's actually coming out of the spindle and grabbing the tool. And that thing's responsible for centering the tool. It's responsible for holding it securely, and it really should be surgically clean, because if it has debris or if it has excessive wear like this one here that's rotating, you can see the wear facet there. What it does is it fails to do those two things. It doesn't hold the tool on center. That wears tools out way faster. And it doesn't hold it securely. You'll get tools slipping out and breaking. It basically is responsible for creating a lot of the milling issues that come up from on tech support lines. And so by just implementing a good procedure for keeping the collet clean, you'll eliminate all that headache. It's super easy, low-hanging fruit stuff to do. Our general rule here is if you're at like a medium production, say you're running 20, 30 units a day, you should be doing your collet cleaning weekly at minimum. If you're doing more, you really can't keep it too clean. You know, and that actually kind of goes along with the next slide here, which is calibration. They're very, very closely related. Nick, go ahead and give me your spiel on calibration.
So there are different machines out there. Some of them require calibration daily. Some require calibration pretty much never. It depends on the type of machine that you buy and what's going on with it. Some of the machines are all, like Greg said, or we'll probably talk about, they're all made of aluminum. Majority of the insides are. Aluminum has a high expansion rate when it comes to temperature changes. A couple years ago, there was a customer that called in and said, you know, I'm getting these lines around around the restorations halfway through my day. I don't understand what's going on. And I asked him, you know, can you FaceTime me and we'll walk around your lab and see what's going on. We walked through a room that was not temperature controlled. And in the morning, the room was about 50 degrees. About lunchtime, the room warmed itself up to about 75 degrees. And we finally figured out, after about a month of going through all of this, of doing tech support to try to fix this mill, finding out that it's a temperature swing that these mills are going through, because they were all doing it. We didn't know, you know, something had to be miscalibrated in the software, because why would they all do it? It doesn't make sense. They're all calculated on the same machine, you know, on the same computer, but they're all experiencing this. So we reinstalled the software, got rid of it, put new updated software on it. We even decided to use a competitor's software to validate, like, oh, it's not the software, it's the machines. You know, like we went very tiresome through this.
Trial and error. It comes down to temperature. Gotta love it.
Yeah, all just from the temperature. The other thing is read the manual. The manual gives you really good advice on how to calibrate it. Also, we'll talk about cleanliness even more. Continue to keep the machine clean. Have some isopropyl alcohol and a brand new spick and span microfiber cloth, so you can clean the probe itself, clean whatever calibration jig goes in the machine, or clean the touch-off sensor. You know, the cleaner the machine is, the longer it's going to last.
The precision device.
Yeah, it is. I mean, you have to. I mean, you don't necessarily need to baby it, I would say, but I would baby it. You know, it's probably the second most expensive thing in the lab, if not the most.
Yeah.
Take care of it. You want to get the most value out of that machine that you can. And by keeping it clean, or having a cleaning person take care of it and maintenance it all the time, verify how many units you're doing in it, you know, verify the hours on the tools. There's a lot of different consistencies to keep your machines in check, where you can quickly realize, oh, this is starting to go out of calibration, because you're on top of it.
I'll add a little bit more on calibration here before we move on. So it helps to know about why you need to calibrate a machine. And I explain this to whoever will listen to me about it. The reason a machine loses calibration is because it references every single one of its movements from a home position. So that's 0. You know, when you boot your machine up and it does its little movement, that's zeroing out. Everything that it's told to do is based on that, and it stacks. So your machine is a mechanical device. There's no such thing as a perfect mechanical device. And so as it's running, it's got a little tiny bit of slop in it, and that slop will stack over runtime. And so the longer you run it between calibrations, the less accurate it can get, because it's losing its idea of where it is in space. And so calibration is basically, it's a reassessment of where home is, right? So that's just one thing I like to tell people. Understand why it needs to be calibrated, and then you'll kind of keep it more in the back of your mind and do it on a regular basis. You know, Sierra Dental Tool is a tool manufacturer, and so I got to throw some tool content in here. And so the biggest thing that I like to drive on tools is it's all about cost per unit. You know, we want to know exactly what a crown costs us to produce in the lab. You know, most labs know what their zirconia cost is. They know what their labor cost is. You know, they amortize the machine over however long it's running, and you know exactly what it costs. But time and time again, I come across people who don't even track the tool life. And if you're doing that, and you're using like an eBay tool or a Chinese tool or something that's, you know, not exactly the best thing to use, and then you switch to a Sierra tool, you're gonna see a huge decrease in your cost per unit. You know, like generally, depending on, you know, a lot of the different variables, we're about 17 cents a unit with our nano die, which is spectacular compared to some of the cheaper tools out there that can be had, you know, less upfront cost. You know, they'll be around the 50 cent per unit mark. So that's a very significant thing to keep in mind. And then it's about selecting the right tool for the material. There are different tools for different materials. I'll get into that in the next slide. And then consider also that the effect the tool has on your unit, because it is the last thing that's in contact with your design. It directly affects your internal-external remix, which of course affects your labor and affects your bottom line directly. So it's got direct effects on cost per unit, and then indirect effects all through the entire digital production chain. So I have to throw a little shameless plug in here for Sierra. Our bread and butter here is the nano die. It's the lowest cost per unit that you can get out there. And then our next most popular tool is the razor sharp line. Now that one's for PMMA and wax, and it's special because it's got a super sharp cutting edge, which those materials really love. So we get better life, better surface finish, that sort of thing. Then a lot of people don't know, we also have grinding tools that are also very high quality, and you know, we're bringing the value to the lab there. And not as many labs here in the US are running titanium, but those who do and run our Tyco line are very happy with it, because we've got a proprietary geometry that's been designed specifically for those dental alloys, and then a proprietary coating technology which actually likes to run hot. That's a whole nother subject matter, but we 2 to 3x the life of a conventional tool in those materials. So you know, again, Sierra is all about bringing value to the lab, and we want to help you guys save money and be more efficient. So this is kind of going to be Nick's whole deal, is the finishing side, but you want to think about, you know, your labor efficiency. You know, whether you're doing certain steps in the green state versus the hard state. And then, you know, we've also got some points on glazing and that sort of thing too. So here you go, Nick, have at it.
Yeah, so I'm going to reiterate this designer-finisher communication. They need to be married together when it comes to finishing these units or developing quality units in your lab. it's not good for the ceramist or the finisher to be spending minutes grinding something that should have been taken care of in the design. The crown should come out of the mill. You're 3 to 5 seconds removing the connectors that are still remaining on the unit, flipping the unit over, and then going inside of it, which we'll talk about next, but finishing the margins. What I see all the time is too many people get the case out, it wasn't designed right, and 30 minutes goes into that crown, finishing it. I believe that 90% of the time should be in the mill or the design side, and only 10% of the time should be finishing the case. That includes glazing. Overall time actually working on the unit, not being in the oven firing, of course.
Right.
The other thing is really spend quality time designing. Having the finisher sometimes work really close to the designer, like sitting next to him on 100 cases, will really set the efficiency level of the finisher later in the day. I can't reiterate how many times finishers spend time recontouring a crown because the designer just didn't know, maybe lazy, maybe they weren't feeling well. Who knows? Maybe it was a Wednesday or a Friday afternoon that they're just trying to get out.
Another theme that we see pretty often is there's always the designer, usually a young guy. He's just having at it. He's doing an awesome job, or he thinks he's doing an awesome job sometimes. And then you've got the guy in the back, the finisher, just sitting there pissed off that he's grinding away and taking an hour to recontour a molar, and they're not talking to each other. Those two guys need to be best friends. So if that's probably a good key takeaway here is make sure your designers and your finishers are talking to each other. Force them to eat lunch together.
Yeah, and the finisher usually is more mature in age and have every cuss word in the book to say about the guy designing. It's extremely entertaining to go in and hear it.
Oh yeah.
Let's move on to margins and when to finish them. There's two schools here. I'm an advocate on finishing it in the green stage. The material is easier to work with. I always draw a red line on the inside of the unit, like I was talking about, and then coming back with a green state specific wheel, stone, or a mandrel held item like this, and just contouring the margin enough to get that feather edge that we're looking for. Again, the more you do it, the better you get at it. Because as soon as it gets out and gets centered, now you're working with something that's, 400% harder, if not higher than that. Your only way to reduce it is with something with diamond impregnated with it. So if it creates sparks, you're getting microfractures. You're running it under water, and now the whole place is a mess because you've got so much spray going on. A big advocate on cleaning up the margin or any contouring that you need to do it in this stage. But time and time again, the guy that's cutting the units out is usually the same guy that's taking out the trash for most places. They don't believe that it needs a skilled technician to work on this.
You do.
Because they're thinking about, I need to get that unit in the oven and get it out the door, not realizing that if I get that unit in the oven and it's polished and it looks good, it's going to come out and drop right on the model, and you just pretty much need to glaze it. Like, it's a big time saver to spend a few minutes here than a half hour later. But you're not contouring the crown here. You're just cleaning up where you put the two connectors on the lingual. You're cleaning up any other area. Maybe you're redefining the anatomy a little bit because you felt that using that 3.3 millimeter tool that we discussed earlier takes 3 minutes to do, but you can do it in 10 seconds because you're just, the area that you want to elaborate on in that. Let's move on to the next slide, Greg.
Yeah, sure thing.
So the final thing that I've done is when you're spending that time polishing it in the green stage, when it comes out of the oven, it has a really nice pearlescence effect to it. Years ago, I was pushing, let's just polish these bad boys up and get them out the door. It's great for natural dentition. Saliva doesn't stick to it. It has a nice feel for the mouth. But then it was that Bruxer-esque crown, more brawn over beauty type situation. And now with the newer materials these days, the glazes that are out there these days, we can compete with ceramics now. It's pretty phenomenal. Polish the occlusion, and then the first thing what happens when you glaze it, you'll notice that the glaze is dull unless you overglaze it. You'll have a the zirconia actually pulls it into it with its porousness. Once that happens, you can add your characterizations. I use an endophile, and I go into the fosses, and I go into the pits, and then I'll come back with a little bit of violet color and do my mamelons or the lobes of the crowns, and then I'll do a nice like warming of the neck of the crown, and then put it under the oven, heat it up so it dries in place, and then, I have some aerosol glazes that are amazing to keep everything in position, or take your time and just put your glaze on it, and then always stick the crown up in the oven to solidify the glaze in its locations. There's a lot of times I'll see people glaze a bunch of units, throw them in the oven, they come out, and all the shade is gone to the neck of the crown. It's lost its effects that you're putting into this thing. Take a little bit of time and pride to make this happen, because this is what the patient's getting in there. This is what the patient sees. This is what the doctor is evaluating the work on, is this last process.
Oh yeah. Well, I think a way to sum that up is the drop down crown that comes out of the oven and fits perfectly and it's ready to glaze is not a unicorn. It's doable if you control all the processes very tightly in your digital workflow. And so that should be a goal that everybody has, and if you're active, looking on Facebook and other webinars that Zahn puts on, it's pretty clear that labs are getting really good results out there with zirconia. The materials are wonderful. I mean, when I first started with zirconia, it was it was a nasty looking crown. I mean, they worked. It's a gold crown replacement was the marketing. You don't have the gold, but it's going to function, right? So with all that, we're hoping that that listening to me and Nick kind of have a conversation around digital production has helped, and maybe you've picked up a little bit of insight here. And I was thinking earlier, if we can affect one person positively and help them save an hour a day, or get their unit cost down just a little bit so that they can be more competitive out there, then this was way worth the time. And so, it's just as a little review, think about the digital production chain as one entity, but consider all the parts and how they work together. Communication in the lab, can't drive that home enough. We probably have beat that horse a little bit in this presentation, but that's okay. And then, time is money. Think about getting the mill running right away, and look for waste in from a time standpoint. So we'll open it up to some questions here. If anybody wants to type anything in, we'll give it just a few minutes. I think we're doing okay on time. And let's see. I don't think any of them have come in yet. So, sometimes you don't get questions on these. That means you did a good job because we were thorough.
That's awesome.
Yeah, right. I see Crystal Connors said hi. Hi, Crystal.
Yeah. Hi, Crystal.
Yeah. Well, you know what? We'll just leave it there then. And I'll invite anybody watching this now or at a later date on YouTube. Go ahead and reach out to Sierra if you need to. Nick and I really enjoy talking to labs and helping them out. A lot of times it's not even about tooling. It's about CAD CAM in general. And we're there to help you guys. The Sierra team, the Zahn team, everybody's got the laboratory's best interest in mind. We're all in this together. And the industry is a small industry, and we want to help affect it positively. So with that, I'll go ahead and close it up. And Nick, I'm sure everybody's concerned about the virus thing that's going on right now. Just everybody stay safe, wash your hands, stay away from humans. Social distancing works, so keep that in mind. I appreciate you guys. Thanks for taking the time.
Real quick here, though, if you guys need to call either one of us, go ahead and FaceTime us sometimes, because we can see stuff a lot easier that way. And in today's era of social distancing, we're not traveling. Like, it's just not safe. So feel free to call us up and ask us for assistance. I mean, we're here for you guys. Okay?
Oh, yeah. I've been using FaceTime probably 10x more than I usually do now, it seems.
Yeah.
So, and by the way, Nick likes to be called at 3 a.m. So there's his cell phone number right there if you want to do that. So
you'll get my zombie conversation.
Nice. Okay, guys. Well, Katie, did you have any closing notes or anything, or we have a wrap on it?
We're good to go. Thank you guys so much for partnering with us on this webinar. I think this was some really great content and could be really helpful. And if anyone missed anything, we will be posting this on YouTube in the next 1 to 2 days.
Hey, thanks, Katie, and thanks to the Zon team. Stay safe,
Thanks, everyone. Have a great day.
Bye, guys.